This video is going to hopefully remind you about balancing chemical equations because it's something you may have learned back when you were in middle school. This is a page in your packet, and this is how I introduce balancing equations. So I like to say what happens in a chemical equation stays in a chemical equation. And what I mean by that is if we look at this example right beneath it, how can you fix or balance this equation? Well, it has H2 gas plus O2 gas, and then after the reaction we've got H2O gas, water vapor. Well, if you look at it, it looks like 2 hydrogens go in, 2 oxygens go in. But then in our products, we only have 2 hydrogens and 1 oxygen. So it's not balanced. It needs to be fixed. So before we can talk about how to fix that, let's think about what do formulas mean. So the next example says how many oxygen atoms are in K3PO4. Well, that subscript of 4 only applies to the oxygen, and it's saying that there are 4 oxygens in that compound. So then what if we put a coefficient of a 3 in front of K3PO4? Well, what that would mean is I've got a K3PO4, and I've got another K3PO4, and I've got another K3PO4. Well, if each one of them has 4 oxygens, then when I add those together, I'm going to get 12. The easier way to look at that would be to say this coefficient of 3 is going to distribute to everything in the formula. So I would have 3 times 3 potassiums, 3 times 1 phosphorus, and 3 times 4 or 12 oxygens. The last question says, is H2O the same thing as H2O2? Well, H2O is water, and H2O2 is hydrogen peroxide, the brown bottle in your bathroom. No, those are not the same thing. So if we go back to the equation we were looking at balancing, if I just wanted to say, well, 2 oxygens went in, I'll just sneak a little 2 right there. You've now stopped making water as your product and instead made hydrogen peroxide. So you've not balanced this equation, you've changed it to a completely different chemical equation. So no, don't do that. So let's take a look at the law of conservation of matter. What that law says is you can't create or destroy matter. Whatever you start with before a chemical change has to be present after the chemical change. You can change what it looks like, what it's bonded to, but you cannot make or destroy matter. So if I have this equation, it's similar. It says nitrogen gas and hydrogen gas are going to react and they're going to form NH3 gas, which is ammonia. I want to know, how can I tell is this equation balanced? So the first thing I do is I make a chart of my reactants, which is starting, and products, which is what I'm going to end with. And I count up how many I have of each element. So N with a subscript of 2 means I have 2 nitrogens. H with a subscript of 2 means I have 2 hydrogens. Those are both on the left of the arrow, so they're reactants. Then if I look on the right of the arrow, this formula has just N, no subscript, which means there's just 1 nitrogen. And then the H has a subscript of 3. Meaning there are 3 hydrogens in it. So are the number of atoms equal? Well, no. I've got 2 nitrogens and only 1 on the product side. And then, so is this equation balanced? No. I don't have equal amounts on both sides of the arrow, so if you picture like a teeter-totter, this is not balanced. So this is how we balance equations. What we need to do is count the number of atoms of each element in the reactants and products. That's what we just did on the other side. Here's the same reaction. I'm going to write the 2 and the 2 and the 1 and the 3. Next, we want to balance just one element at a time. So we just pick one and say we're going to fix that. And the way we fix it is we're going to put coefficients in front of the chemical formula containing that element. We are not allowed to change subscripts, we're not allowed to add subscripts, and we're not allowed to put numbers like right smack in the middle of a chemical formula. The way we pick which element we're thinking of starting with is this box over here on the side. It's pronounced Minho, and it's the suggested order of balancing elements. If we had a metal in ours and it wasn't balanced, we would start with that. Later on in the year when we get to polyatomic ions, if you have one of those that's not balanced, you do that next. What we have are some nonmetals and hydrogen. So our nonmetal is nitrogen and hydrogen is next. So we're going to start by trying to fix nitrogen. Since we had 2 in the reactant side, I need the same amount on the product side. I want this to be a 2. I go up to the chemical equation and I see if I put a coefficient of 2 in front of ammonia, that 2 is going to distribute and give me 2 nitrogens, but it's also going to double my hydrogens. So I now have 2 times 3, I have 6 hydrogens. So I've fixed my nonmetal. Now I'm going to try to fix my other element. I'll fix hydrogen. So there are 2 on the reactant side. It's diatomic, which means they come in 2s. And on this product side, I have 6. Well, I need to put a number here that when I multiply it by 2, I'm going to get a total of 6. So if I put a 3 coefficient, that means I have 3 sets of H2. So I've got H2, H2, H2. That's 2, 4, 6. So that fixes my hydrogen. I don't have to change my nitrogen on the reactant side, so there's like an invisible 1 coefficient in that blank right there. So when you balance an equation, the last thing you do is check it and make sure all the coefficients are in the lowest possible ratio. Sometimes it happens that you make a tiny mistake and everything here would be doubled and you would have like 2, 6, 4. So if you see all even numbers, go back and divide them all by 2 and bring them down to that simplest possible ratio.